And now moving to the selection sort algorithm. Okay, what is selection sort here and how is it different from the bubble sort? So in the bubble sort, you just kept iterating and kept comparing. What you do is that it repeatedly finds the minimum element from the unsorted part. Okay, you find the minimum element and you swap it with the first unsorted element. Okay, and so basically what happens is that you decide a minimum index and then you find out that okay, your value is less than, then this is your minimum index. Okay, and then you swap the element. Let me visualize it for you. So this will be an unsorted array like this. Okay, this is the sorted array. But how? So on this unsorted array, what you do, you iterate. First you select the 64, all right, and now then you select, internally you run another loop starting from this 34. Okay, means an index after the current index to the end of the array. Now here you check whether this 34 is less than your current index. Okay, yeah, if it is, then your minimum index is set to the current index of the internal iteration, that is the index of 34. Okay, like this, and then you move on to this, then the minimum index is now set to this, move on to this, and here 11. Now this will be replaced with this one. Are you noting it? This will be replaced with this one if the minimum index is not as same as this, because you don't want to swap with this, right? The same values. This is how the selection sort will work. So the 11 will go to here, the 64 will go to here. Now you move on to here and then you compare again. That is how the selection sort works. What are the steps to implement it? So the steps is that start with first element and then find the smallest element in the unsorted part, not unsorted array, the unsorted part. Okay. What are those unsorted parts? Means those two you have selected, 64 you selected, 34 you selected, between these two, which is the minimum element, the smallest element, you do that. Okay. Now swap the smallest element with the first unsorted element, means the smallest element that you received was 11. Now this will be swapped with 64 that was unsorted. Okay. Now you repeat this process until the array is sorted. These are the steps. So are you able to catch it? Are you able to understand the steps? Can you code the logic? Pause the video and try to code the logic. Otherwise, if you're not able to code, then I will be showing you. So before that, the time complexity is O(n) square. Space complexity is O1 till now. Okay, we haven't yet moved on to the O(n) space complexity. Space complexity till now is O1 only in our algorithms. Let me start implementing the selection sort. Function selection sort here. So what I will do is that const n equals to array.length. This will make our life easy, and like this, like this. So if main index. So what did I do just now? Let me tell you. At the first you selected this element, okay. Now you set the min index, the smallest index, for determining the smallest element. Basically you want to reach out to that smallest element which can be placed at the first, okay. So you keep iterating, okay, it is less than 64, yeah, it is less than 64, yes, it is again less than 64, again less than 64, less than 64, again less than 64, and then, you know, like you are moving it to here. But are you always comparing with 64? No, that's also not true. So ARRJ is less than ARR, min index, okay. So currently C is set to I, means that you compare with 64. Okay, you keep comparing with 64. Now this is 34. Now you compare with 34. Okay. Now you compare with 25. Of course. Okay, it is again less. But what if there was a large number? You compare with 12. Okay, but this is large number. This will not be set to the min index. And if the min index is not the same as your current index, then only you will be swapping, because you don't want to swap with the same values, right? You will be swapping when it is actually needed. Okay. So what we will do is that we will be adding the logs here. Okay. Here are the logs, and now I will be running this code. Oh wait, I did not actually call the function. So you see 3464, 2534 comparison, 1225 are being compared, 2212. Okay, now this did not become the min index. 12 is repeated, 11 12, now 11 is less, 90 11 again, now 25 34, because you moved on to this, and then you kept on doing this operation until your array is sorted. Now your array is sorted like this, okay. So this is how your selection sort algorithm works in TypeScript.